Good morning. My name is Mackenzie Vedas, and for my lab experiment 10, determination of molar solubility titration, I will be going through finding the molar solubility and finding the KSP as well as the setup for this titration. So the first thing to take a look at is the setup for the titration. So here I have drawn what our titration setup would look like. So we've got our clamp stand, we've got our burette, we've got the titration flask, which is normally like an Erlenmeyer flask. And then for the clear solutions, we've got our analyte, which is going to be our calcium hydroxide, and we've got our titrant, which is our hydrochloric acid solution. So we have 0.5 molars hydrochloric acid, and we have got 25 milliliters of the calcium hydroxide plus 2 drops of methyl orange, which I will go through in a moment. So then when we are looking at the stock solution for calcium hydroxide, it's super saturated. So on the bottom here we have what's called the precipitate, and on top we have the supernatant or supernatant, I'm not exactly sure how it's pronounced, and it's also a clear solution, so that's why they're both clear. And you want to make sure that when you're separating the precipitate from the supernatant, that you don't get any of the precipitate, because that will affect the KSP value and the molar solubility when you go to calculate it. So on the bottom here, we are using the methyl orange indicator because we are dealing with a highly acidic solution. Hydrochloric acid is a strong acid. So our pH would not be above 4.4. This is alkaline. Our endpoint is going to be between 3.2 and 4.4. And when it's super acidic, it's going to be like bright red. So continuing on, now that we've looked at the setup, we're going to take a look at finding molar solubility of the calcium hydroxide. So before you can find the molar solubility, you have to do a few steps beforehand. So the equation for molar solubility is half the concentration of hydroxide ions. And the reason it's half the concentration is because one calcium ion is equal to half of a hydroxide ion, and that's how we found the solubility equation. So first we need to find the moles of hydrochloric acid, and then you can find the moles of OH, which is the hydroxide ion. So we take the liters that we found multiplied by 0.5 moles, because this is our given amount, over 1 liter, because that was the molarity. And then we get our moles of hydrochloric acid. So then we can then find our hydroxide ion, which is equal to half of HCl. So we simply just divide the value that we got by 2, and now we have our moles of hydroxide ion. Now we have to find the equilibrium of the hydroxide ion, and that would be the 0.0027 moles that we found here, divided by the 0.025 liters of calcium hydroxide. And we have this value because that was the endpoint that we found while doing the titration, and that will equal 0.108 molar. So now that we've got this information, we can find solubility. So we are going to take this equation and then just basically plug in what we have. So we have half of the hydroxide, and that would give us 0.054 molar of calcium hydroxide. Next, we're going to look at finding KSP. So the equation for finding KSP is half of the hydroxide ion cubed. So basically what we did to find that cubed value is, if you look at the original calcium ion, which is first order, and then hydroxide ion, which is second order, so if you replace it, to simplify it, we get half OH to the cubed. Now for finding KSP, we simply plug in, there's the half, there's the 0.108 molar, but now we cube it, and that's what this looks like. And then our final value is 6.2986 times 10 to the negative 4 molar. Thank you for watching and have a nice day.